Good morning, everyone, and welcome. I'm Desta Tatel, and I'm excited to be here with you today. We will be exploring the application of physics in various fields. On this first slide, you'll see the title of our presentation, Grade 12 Unit 1, Application of Physics in Other Fields. We'll briefly go over how physics connects to different areas of work and everyday life. So, let's get started and discover the many ways physics influences our world. The modern defense force is made up of different branches, including the Air Force, Army, Navy, and Space Force. Each of these branches requires specialized knowledge and advances in physics. For example, they all rely on technologies like laser guidance and satellite systems, which involve modern electronics, optics, and sensing systems. They also depend on high-energy density physics, atomic and nuclear physics, hydrodynamics, and the physics of advanced materials. Specifically, the Navy needs expertise in oceanographic physics, such as understanding how sound propagates through water, deep ocean currents, and meteorology. The Air Force, on the other hand, focuses on turbulent fluid flows, navigation, long-range observation, and pattern recognition. The Army's needs include night vision, all-weather capabilities, and techniques to avoid detection. In space-based systems, advanced optical physics plays a crucial role in satellite surveillance. This same physics is also vital for manned and unmanned aircraft, missiles, and even rifles. All of these points highlight how physics underpins the technology and capabilities of modern defense forces, connecting scientific principles directly to national security and defense strategies. Let's start by breaking down what radar actually stands for. It's an acronym derived from the phrase radio detection and ranging. Essentially, radar is a system that uses radio waves to detect and track objects. These objects can be ships, vehicles, aircraft, missiles, or other targets, and they are at various distances from the radar station. What makes radar really useful is its ability to gather information about these objects, like how far away they are, what we call their range, and where they are located. It does this by radiating electromagnetic signals toward the target and then listening for the echoes that bounce back. These echoes tell us a lot about the target, such as its position and distance. Now, let's talk about how the range is actually calculated. Imagine the time it takes for the radar signal to travel from the radar station to the target and then back again. We call this total time t. Since the signal has to go to the target and return, the total distance covered by the signal is twice the range. So 2r using the simple speed-distance formula, we can find the range r if we know the speed of light, which is the speed at which these electromagnetic signals travel. By measuring the time t and knowing that the speed of light, c, is approximately 300,000 kilometers per second, we can determine the distance to the target. This is the fundamental principle behind radar technology, and understanding this helps us appreciate how radar systems are so effective at tracking objects over long distances. Today is Saturday, November 1, 2025, and we're focusing on the Grade 12 Physics Department here at Werda Higher and Secondary School. As we continue, let's delve into some key concepts that are crucial for understanding this part of the course. This slide is a continuation, so I want to make sure we're clear on the main ideas. Remember, the goal is to connect these points to the bigger picture of physics principles we've been exploring. Think about how these concepts relate to real-world applications and the fundamental laws that govern everything around us. We'll keep it engaging and make sure you see the relevance of each point as we move forward. Now let's take a closer look at how radar works. Essentially, radar mainly consists of two main parts, a transmitter and a receiver. These two components work together to detect objects. Interestingly, they use the same antenna for both transmitting and receiving signals, which makes the system more efficient. Here's how it operates. The radar transmits a signal in the direction of the target, like an airplane or a ship. When this signal hits the target, it reflects back in various directions. Some of that reflected signal makes its way back to the radar antenna. Once it arrives, the receiver picks it up and displays the information on the radar screen. This process is crucial because it allows us to determine the location and sometimes the speed of the target. The key point to remember is that the radar sends out a signal, the target reflects it back, and then the radar receives and processes that reflected signal. All of this happens very quickly, enabling real-time tracking. Connecting this to the overall theme, understanding this basic operation helps us appreciate how radar is such a vital tool in navigation, weather monitoring, and even defense systems. Today is Saturday, November 1, 2025, and we're focusing on the physics curriculum for grade 12 at Werda Higher and Secondary School. As we continue, let's delve deeper into the key concepts that underpin our understanding of physics. This slide builds on what we've discussed earlier, emphasizing the importance of grasping fundamental principles. Remember, the goal is to connect these ideas to real-world applications, making physics more relevant and engaging for you. We'll explore how these concepts interrelate and their significance in solving complex problems. By the end of this section, you should see how a solid understanding of these core ideas enhances your overall grasp of physics and prepares you for more advanced topics. So, let's keep these connections in mind as we proceed. Radar is primarily used for military purposes, and it's actually a crucial part of any air defense system. Its main role is to detect targets, such as incoming aircraft or missiles, and then guide the weapons, whether they're defensive or offensive, to intercept those targets effectively. But what's interesting is that radar isn't just limited to military use. It also has many civilian applications that are incredibly important in our daily lives. For example, in air traffic control, radar helps manage and guide airplanes safely through busy skies. It's also used in weather observation to track storms and monitor atmospheric conditions. Ships rely on radar for navigation, especially in poor visibility conditions like fog or storms. Beyond that, radar can be used for environmental sensing, remote area observation, and even planetary exploration. So, while radar is a powerful tool for defense, its versatility makes it valuable across many fields that impact us all. A missile is a weapon that is either rocket-propelled or jet-propelled, designed to deliver an explosive payload with high precision and at high speed. Jets, of course, draw oxygen from the air to burn their fuel, while rockets carry their own oxygen supply, which makes them more independent of atmospheric conditions. Missiles come in different types, but two of the most well-known are cruise missiles and ballistic missiles. Cruise missiles are jet-propelled throughout their entire flight, meaning they use engines that continuously produce thrust, allowing for controlled and sustained flight. On the other hand, ballistic missiles are powered by rockets only during the initial phase of their launch. After that, they follow a curved trajectory, influenced primarily by gravity and air resistance, much like a projectile in physics governed by Newtonian mechanics. The key difference hinges on the flight path. Cruise missiles can be controlled during flight by adjusting their engine thrust, which helps them conserve momentum and stay on course. This control allows for precise navigation, especially over long distances. Now, a missile isn't just a simple projectile. It's a complex system composed of many electronic, digital, and mechanical subsystems. These work together to guide the missile from the launch point to its target. There's continuous radio communication between the missile's onboard control unit and the launch controller, which ensures proper target tracking and that every part of the missile functions correctly throughout its journey. In essence, missiles combine advanced technology with physics principles to achieve their purpose, and understanding these key concepts helps us grasp their capabilities and applications in modern defense systems. Human eyes are sensitive to visible light, which includes colors like red, orange, yellow, green, blue, and violet. However, infrared light is just beyond what our eyes can see. Instead, infrared is detected by special devices designed for that purpose. All objects, including people and places, emit infrared light, and the amount they emit depends on their temperature. These infrared devices are particularly useful because they can identify objects that are hidden or not visible with normal light. In fact, infrared vision is widely used by the military for many reasons, such as night vision, navigation, hunting, and detecting hidden objects. Infrared imaging systems, like infrared goggles, create electronic images based on temperature differences. Hotter objects appear brighter in these images, while cooler ones are darker. It's important to note that in these images, you can't see the actual colors of the objects. Instead, different colors are used to represent temperature differences, and these colors don't correspond to the real colors of the objects. For example, night vision images are often green because green enhances our natural ability to see in low light, making it easier to spot targets at night. So, infrared wave detection is a vital technology for night vision applications, helping us see in the dark by interpreting heat emissions instead of relying on visible light.